In this video, we're going to look at hypothesis testing. We're going to look at this through the use of several examples. For our first example, we're to test the claim that when parents use a particular method of gender selection, the proportion of baby girls is less than 0.5. We are to assume a 0.05 significance level is used. We're to assume that the sample data consist of 36 girls and 81 births, so that the sample statistic of 4/9, and that's just 36 over the total there, results in a z-score that is 1 standard deviation below 0. So in order to do a hypothesis test, our first thing to do is to write our actual hypothesis. And so we're going to write our two hypotheses. First, our null hypothesis, so H naught, and then our alternative hypothesis, which we can use either H1 or HA. As we look up here, this is talking about a proportion, so we're going to use P as our parameter. And this says less than, but we know the null has to have the equal to statement, so we say P is equal to 0.5. And then as our alternative, we say P is less than 0.5, and we have these being mutually exclusive. They don't overlap at all. Previously, we would then go look at a p-value, but we don't have a p-value. It's not given in the problem, so we're going to have to pull in some of the statistics that we've learned so far in this course. So the first thing we know is that proportions are going to use the normal curve, or the normal distribution. We had looked at means using the t-distribution and standard deviations using the chi-squared distribution, but proportions were the first one we had done with confidence intervals, and they always use the normal distribution. We also know from the alternative hypothesis that this is a left-tailed test, and I usually like to draw a picture of that. So here's my normal curve, and it tells us right up here the z-score for our proportion is 1 standard deviation below 0. So z-score possibly about here of -1, and less than that would be this area or this region. So what we're going to do is we're going to actually look up this -1, and that will give us an area or a probability for this shaded region. So I'm going to go to my charts, and you see here I have the z-score chart. I'm looking for a z-score of -1, so I'm going to scroll down a bit, and -1.0, so 0.1587. So that gives me this particular area is 0.1587, and that is my p-value. We could conclude our hypothesis test at this point, but there are a few other things that I want to talk to you about, and I feel like it would not be a true statistics course if I didn't at least mention these to you. So, in statistics before, we mentioned a critical value, and the critical value is that value that separates what we want from what we don't want. And the critical value can also be used to make a decision about a hypothesis. We're going to stick with the p-value method by and large, because that is what's most commonly done at this point in time. But the critical value was more common before everybody used software to do statistics. So with the critical value method, what we do is we would look up what z-score would give us this significance level. So we know that alpha is equal to 0.05, and so that alpha is a probability or an area. It's a probability of an error. And so where would this area down here be 0.05? So we want some area down here, and we want this area to be equal to that alpha level. And that area would also have a z-score associated with it, and that would be called my critical value. So let's go back to our z-table, and if I'm looking for an area of 0.05, we've done this before, it's right between these two, it's at that little asterisk. So if I go to the bottom of my chart, that gives me a z-score of -1.645. So this z-score is negative 1.645. And then I can compare these two, my test statistic here, the negative 1, and my negative 1.645. If my test statistic is in this red area, the critical area, then I would make one decision. In our case, that test statistic is not in the critical area, so we'll make the other decision. So that's how those words come into play, and you'll see them in textbooks. Very rarely will you see them in any research article at this point in time, because almost exclusively everyone uses the p-value. So we'll go back to the p-value to make our decision. So we want to compare alpha and the p-value. Our alpha level is 0.05, and our p-value we found from the area, and it's 0.1587. So the p-value is the bigger one, and so we have p is high, so null can fly, which means that we think the null is the correct solution. We don't have evidence to reject the null. And so we would use in statistics words fail to reject null, and then we want to put that into Common English. So in the Common English, we either want to use the significance level or the 95% confidence that coordinates with that. And so one way of saying this is at the 0.05 significance level, we do not have sufficient evidence to support the claim that the proportion of girls is less than 0.5. If we were looking at the critical value, because our test statistic is not in this critical area, we don't think that our data is all that rare, and so we would reach that same conclusion if we used the critical value method. All right, let's look at a second example. And so still dealing with the same scenario, but a little different numbers. We're to test the claim that when the parents use a particular method of gender selection, the proportion of baby girls is different than 0.5. We're to assume a 0.01 significance level. We're to assume the sample data consists of 66 girls and 144 births, so the sample statistic is 11 over 24, and it gives us a z-score of 1 standard deviation below 0. So we're going to start out by writing our hypothesis. So we have H0, and we have our alternative hypothesis. And again, we're dealing with proportions, so proportion, null has to have the equal to, so equals 0.5. And the alternative proportion, and we have here different wording. So it says is different. Doesn't say is less than, it says is different. So different means it could be less than or greater than, so we have to go with not equal to. And so again, with proportions, we're going to use the normal distribution. I'm going to draw my curve. And this one is a little different than the previous one. Because of the not equal to, it would be called a two-tailed test. The value could be lower, or the value could be higher than the 0.5. So it could go either direction. These should be symmetric. We're told that this test statistic is a z-score of 1 below 0, so that gave us -1. And then by symmetry, we would also use +1. So we have to look up the -1 to figure out the area, and we do that with our z-score table. And so for -1, we get an area of 0.1587. So this area right here, 0.1587. And by symmetry, this area right here would also be 0.1587. So because it is two-tailed, we would say that we would reject this null if we had a value here or here, either way. So our p-value is gotten by adding those two together. So we have both of these instead of just one of them, like a one-tailed test. And so that gives us a p-value of 0.3174. And truly at that point we have enough information to make a decision. So I want to talk again very briefly about the critical values because they come up in textbooks obviously, but every once in a while in an article as well. So we have up here our alpha value of 0.01. But that alpha value, to come up with a critical area, has to be split between the two tails. So we're going to divide that in half, and that gives us 0.005. So we want the little bit of region out here where this would have an area of 0.05. Excuse me, extra 0 in there. And this little bit out here, and this would have 0.005. And so we want to know what are the critical values, what is the cutoff points for those two little regions. So again, we have to go to our normal table, and we're looking for this exact one that's down here at the bottom. We could have found it up here at this asterisk, and we've done this before. So that critical value is negative 2.575. Negative 2.575 and negative 2.575. So our test statistic out here of -1, +1 definitely does not fall in this little red critical region. So we're going to go back to the p-value though to make our decision. So we want to compare alpha and the p-value. When we look at our alpha, it was given to us as 0.01. We look at our p-value and it is 0.3174. Our p-value is significantly higher than our alpha level, and so we use our rhyme. P is high, so null can fly, and we just mean the null can stand. And so we fail to reject the null because this test statistic is not in our critical region, and so we fail to reject this. This could happen by chance, and it is not extremely rare. We want to, as our final step, put that into Common English. And so at the 0.1 significance level, we do not have sufficient evidence to support the claim that the proportion of girls is different than 0.5.